So, second derivative helps us with concavity, yes? Okay, and then the first derivative test, when we saw that it changed sign, told us where maxes and mins are. The second derivative test is also going to help us find maxes and mins. So basically, if the second derivative, so if we start with where the first derivative equals 0, okay? So you know you have a max or a min maybe, right? If the first derivative equals 0. All right, so if the second derivative is positive, then the graph is concave up, yes? So where on a concave up graph is the derivative equal to 0? At the minimum. You with me? So if I know that the first derivative is equal to 0 somewhere on this picture, it's got to be, it has to have a minimum, basically. Do you see what I'm saying? Like, I can't have something be concave up and the first derivative equaling 0 and it not be at the minimum if it's concave up the whole time. Is this okay? And vice versa for concave down. Now, if they're both equal to 0, so we don't know if it's concave up or concave down, we can't do anything. Is this okay? All right, so this is basically a shortcut for finding maximums and minimums. So given this function, f of x equals negative 3/5 plus x to the fifth. I'm going to shut up and just not read it because it's not coming out of my, the brain, the eyes to the mouth is not going very well for me today. So let's go ahead and find the first derivative. And where is the first derivative equal to 0? I'm going to pull out a 15x squared. I get negative x squared plus 1. So x equals 0, I agree with. X equals 1, I agree with. Anything else? X equals negative 1. Well, comfortable with that. All right, now, let's also take the second derivative. And I'm going to do that from the initial form, not the factored form, because I think it's easier. We feeling okay? All right, so the question becomes, at x equals 0, is there a maximum, a minimum, or I don't know? And all we have to do is say, well, what is the second derivative as 0? 0. So does that suggest concave up? Does that suggest concave down? So at x equals 0, this is inconclusive. The second derivative test is. What about if I do evaluated at 1? I get negative 30. What does that say about my function? It is concave down. You with me? So what do we know about x equals 1? Is it a minimum or a maximum? And then f double prime of negative 1?
30.
positive 30, which means concave up. So at x equals negative 1, we have minimum. Is this familiar, I hope? All right. Why don't we, for fun, can you guys put this in your graphing calculator? Let's look at a graph. All right, so can you guys kind of see why if we look at x equals negative 1, we can see that minimum. At x equals positive 1, we can see that maximum. And then at x equals 0, do we have a max or a min? Doesn't look like it anyway, right? So cool? All right, so let's look at this next one. Change this because it's bothering me. All right. All right, so here I've given you an equation for the second derivative, an equation for the first, and then values where the first derivative is equal to 0. Okay, so are you guys with me that if we have maxes and mins, they occur at these places, yes? That's where all of our extrema are, so we just have to decide, are these extrema or not, yeah? All right, so what should we do? Plug them in to the second derivative. And do we need numerical values for this? Nah. So what do I know about x minus 4 if x is equal to negative 4? Is it going to be positive or negative? Negative. What about x plus 2? What about x minus 2? So when I plug in negative 4, is my second derivative positive or negative? Negative. Which means concave down. So what can we say about x equals negative 4? It's a max. So we have a max at x equals negative 4. Then we do the same thing for positive 1. And I think that ends up being positive, so it's concave down. So we can say we have a min at x equals 1. And then just check 5. What do you guys check 5 on your own? You feeling okay with this? All right. Okay, according to this graph, if this graph is of the second derivative, where is it concave down? Between 1 and 2? Is that it? And if I ask you the y, because that's where the value of f double prime is less than 0. If you said is negative, that's fine. What about inflection points?
1 and 2.
Because at x equals 1, f double prime goes from positive to negative. And at x equals 2, the other way around. Is everybody okay with this? All right, so